Today we're going to look at lesson 2.2, and we're dealing with exponents that have both positive and negative bases. When is the negative sign locked on to the base? I have 4 different examples here. In the first example, negative 3 to the power of 3 without any brackets. In the second example, the negative is on the outside of the brackets. The 3 to the power of 3 is on the inside. In the third example, negative 3 is inside the brackets, but the power is on the outside. And in the fourth example, negative 3 to the power of 3, all of it is inside the brackets. So when does the negative sign matter, and when doesn't it? Let's start with the first one, negative 3 to the power of 3. In this case, the negative sign is not locked onto the base. That means that this problem can be rewritten. The exponent of 3 only applies to the 3 and not to the negative. So negative 3 to the power of 3 actually means negative 1. All times, or brackets, 3 times 3 times 3. How does that compare to the next? Negative bracket when the 3 to the power of 3 is on the inside. In this case, the negative sign is not locked onto the base. We can tell that clearly because it's sitting outside in the brackets. The exponent of 3 only applies to the 3 and not to the entire negative 3. And again, negative 1, bracket, 3 times 3 times 3, close bracket. In our fourth example, the negative sign and the 3 are both inside the bracket. In this case, the negative sign is locked onto the base. The exponent of 3 applies to the entire negative 3. Negative 3 times negative 3 times negative 3. This is a significant difference than the first two examples. Finally, our last example, negative 3 to the power of 3, all inside brackets. In this case, the negative sign is not locked onto the base. The exponent of 3 only applies to the 3 and not the negative 3. And if you look at the final example, open bracket, negative 1, open bracket, 3 times 3 times 3, close bracket, with the exception of the extra set of brackets, looks exactly the same as the first two. Let's look at all 4 of those closely together. In the first one, the answer is negative 27. In the second one, negative 27. In the third one, negative 27. And in the fourth one, negative 27. So by now some of you are asking, does it really matter? Yes. When we start dealing with exponents that are positive, pardon me, not positive, but are even numbers, it has a huge difference. So let's use the exact same breakdown that we did when we were cubing with negative 3, and this time let's just square it. So in the first example, negative 3 to the power of 2. The negative 1 is on the outside because the negative is not locked on. 3 times 3 is 9. So altogether we have negative 9. In the next example, the negative 3 is not locked on, and we can see that it's sitting on the outside of the brackets. So we have negative 1, brackets, 3 times 3, close brackets, and our answer is negative 9. In the third example, the negative 3 is locked inside. When I rewrite that, it's negative 3 times negative 3, and my answer is positive 9. And in the fourth example, other than having an extra set of brackets, it's the same as the first two examples, and our answer is negative 9. In this case, we can see that when the negative is on the inside of the brackets and is locked onto the base, it does matter. When I have an even exponent, my answer will be positive. If I have an odd exponent, like in our first case, I will have a negative answer. We're going to go a little bit further with the parts of our powers. Starting with C on 5, we have negative 2 as our base and 5 as our exponent. We're going to rewrite that as negative 2, all in brackets, so that we know for sure that the negative is a part of our base to the power of 5. When I rewrite that, the negative 2 is multiplied over and over again. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. I've done it 5 times to match the exponent of 5. Let's work backwards on D. I know that I have something happening 3 times. So I'm going to start by writing down that the exponent is 3. With my base, I want to be very clear. The negative sign is not attached to the 6. It is not locked on. So I'm going to write it as negative, open bracket, 6, close bracket. Finally, if I put it together, negative, open bracket, 6 bracket 3. In our third example, negative 4 to the power of 6. Because we know that that negative is not locked onto the 4, I'm going to be extra clear in my base. Negative, and then I have just the 4 in the brackets. The negative remains on the outside. Still to the power of 6, so we still have exponent 6. So this time I'm going to write it 6 times. But watch, I am not writing the negative sign over and over and over again. The negative was not locked on, so it remains outside. The 4 is repeated 6 times. 4 times 4 times 4 times 4 times 4 times 4. When we look at these answers and the breakdown, we can start to predict whether or not the value in standard form is going to be a positive or negative number. In this first one, I had a positive number and an even exponent, so I had a positive answer. In the second one, I had a positive base, and it repeated 3 times. I'm going to wind up with a positive base, or a positive final answer. In our third one, I have a negative times a negative times a negative times a negative times a negative. That negative sign has been multiplied 5 times. Because of that, we can predict that the answer will be a negative answer. When I look at D, 6 times 6 times 6, that part's positive, but the negative that wasn't locked on, that's sitting outside, will force the answer to remain negative. With E, we have the same case. The negative is on the outside. 4 times 4 times 4 times 4 times 4 times 4 will be a rather large number, but when all is said and done, we know for certain that that answer is going to be negative. Here's your homework for today. This will be due next class.